How's it going, class? Mr. Zatola here. So, today we're going to talk about feedback loops, which includes the positive feedback loop and the negative feedback loop, also known as uh, an inhibition. So, inhibition means to stop or slow down something. So, feedback inhibition refers to stopping or slowing down something. So, let's get started. We're going to take a look at one each. Awesome. Okay, so the first thing we're going to start with is the positive feedback loop. Okay, so as you can imagine, it refers to, well, loop is pretty clear, something like a cycle, something like this. So the thing with the positive feedback is what we have is as one thing increases, another thing increases. So essentially what you have is kind of like a runaway train, or sometimes we call it like a snowball effect. For example, one hormone increases, causing another hormone to increase, and they increase until something else causes the items to stop. So let's talk about that. So our most famous situation here is childbirth. Sorry, guys. Girls, so what happens here is as the baby's head pushes on the cervix, this causes the brain to trigger the release of another hormone, which in turn causes the uterus to contract, which in turn causes the brain to release the same hormone as the baby pushes on the cervix, and so on and so forth until the baby's born. So basically it is the baby pushes on the cervix, okay, causes an increase in hormone, causes the uterus to contract, baby pushes on the cervix, increase in hormone, uterus to contract, increase in hormone. So as you can see, they're both increasing, and you're going to see this example in a packet coming up. And that's really how you look at the positive. The positive just keeps building. In terms of childbirth, once the baby passes the cervix through the birth canal and is born, then there's no triggering of this hormone to tell the uterus to contract. Okay, so that's positive feedback loop in a real quick demo. Okay, now we're going to go into the negative feedback loop. All right, and again, here we have another situation where we have a loop. But in this case, what you have is as one thing increases, something decreases or turns off. So in this famous example is your thermostat, okay, in your house. So as temp increases, okay, because the heater's on, right? So heat on, temp increases. The temperature reaches a certain point. The heater turns off. The temperature decreases. So real simple, right? Same thing with an air conditioner. We just can't use heat on, right? We're going to say something else. So in this case, what we're going to do is basically as temperature increases, as you all know, come summer, we have, I'm just going to make that larger, AC on, right? It brings temperature down. And then once temperature's low enough, we have AC off. Hopefully you're lucky enough to have air conditioning. And then when the temperature starts to increase too far, as we come back around, AC goes on. And as we come back around, temperature decreases, AC turns off. We're going to look at another example, which is really the human body example, which is insulin, pancreas, blood sugar levels, right? And that you're going to see in the packet coming up. So this was just a quick overview of the two feedback loops. I also have a video I'd like you to watch for this assignment. All right, everyone. Hope everyone is well. Thanks so much.